Hello and welcome to Technical Utkranti, and today we are going to discuss this question which involves deep copying a linked list. So let's look at the thought for the day. Alright, so these many questions we have done in the linked list, and let's see what the question is. In here we have this complicated looking linked list. So as you know, linked list always have a group of nodes. So these rectangles are the group of nodes, and a next pointer which points to the sequentially next node. In here, there is an additional pointer called the random pointer, which points to any node, not necessarily in a sequence. What we have to do is to write the algorithm which does the deep copy of this particular linked list. Okay. So, firstly, understand what is deep copy. So, firstly, we'll see with the assignment operator. With the assignment operator, we just create another pointer that points to the same object. As a result, if I modify any particular entry in any one of the list, the second list automatically gets modified. So if you see, yeah, I just modified 1 comma 0 of list 1, but list 2 also got modified. So in shallow copy, what happens is the collection of list is a collection of lists, right? So a list is a collection of objects, and this particular list is a collection collection of objects, correct? It's like two dimensional list. So what happens is in shallow copy only the higher level objects have a separate copy, like this will have a separate copy, this will have a separate copy, but the underlying objects or the lower level objects, for them the separate copy is not created. As a result, when we modify this particular entry, we see that both the lists get modified. But if I just change the second list in the list of lists, then let's see what happens. So as you can see, that only list 1 is getting updated, right? So that is the shallow copy. And let's look at the deep copy. So deep copy takes care of having the separate objects at all levels. So if I have this particular thing modified, so as you can see, if I modify only one element of list 1, then then that element of that particular list only get modified. So that is deep copy. So let's understand this question with the help of a simple example we have in front of us. So this question is solved in three steps. First step is to first step is to create nodes. Then second step is to establish random links. And third step is to establish next links. How are we going to do it? So we'll have a pointer I over here. With the value of I, I'll create a copy node. Okay. And I will note down the forward node as well, because this link we are going to break soon. So what we'll do is, while I is not null, what we'll do is we'll create a copy node with the value of I. So I dot val. So this is created. Then we'll note down the forward node like this. Then we'll do the linkage I dot next is equal to C. Then C dot next is equal to F. this, and finally I is equal to F. Okay. So this becomes I. Okay. And this will go on. So again, we'll create the node over here with 2. So this becomes C. Then this becomes F. We have a link established over here. This goes off and this happens. And similarly, when this becomes I, a copy node is created, link is established, this goes off, this points to null. And when I becomes null, we are done with this while loop. So in this process, we have created a copy linked list over here, and we have established some sort of links, and they would be useful in the second step now. So what we'll do in second step? In the second step, the main thing is that we know that if this is I, then I dot next is its respective copy node, right? And we need to find the random linkage, which means I dot next dot random. And this will be equal to I dot random. So I dot random would be what? The random linkage node. And I dot random dot next would be its respective copy node. So I dot random not next. This relationship has to be remembered, and yeah, we will be done. And at the end of the loop, we'll do I equals to next dot next, which will bring I one step ahead in the original linked list. So in this way, we would be able to establish the links like this. So this is random is equals to this. Then this random is will be equal to null. And this is random will be equal to 1. Sorry, here. Okay. Now the last step is to have these links established, the next links established. So for that, one very important thing is to create a dummy node. So in linked list, we create these dummy nodes in order to keep track of the head of the linked list, and you'll understand how. And we make C is equal to dummy. So C dot next will be equal to I dot next. F is equals to I dot next. So this will be F. Then we'll establish the link I dot next is equal to F. So this link will be established and this will go away. And at the last, I will be equal to F. I will be equal to F. So this will become I, and C will be equals to C dot next. So this will be equal to C. Then again we'll do C dot next equals to I dot next. So C dot next will be equal to I dot next. F equal to I dot next. I dot next equal to F, like this. Then we'll have I over here and this gone. And similarly, C will be equal to C dot next. Okay. So as you can see, right, that as these C and I variables are going ahead, the links are getting established as they should be. And at the end, what will happen is this will point to this will point to this, and this will point to this. Okay. So let's jump into seeing the code. So this I'm straight away taking to you lead code side, and this is the first loop wherein we are establishing those crisscross linkages. Then this is the second loop where we are establishing the random linkages, and this is this dummy node creation. So yes, I forgot to tell why I created this dummy node. So as you can see, this C moved ahead as the algorithm proceeded, but this dummy remained as it is in its original position. So dummy dot next is actually the head of the deep copied linked list. So this will serve as a starting point of the deep copied linked list. That's why we had to do this dummy node mechanism, right? And as you can see, I'm returning the dummy dot next as the answer. Right. So as you can see, all the three cases passed. So I hope you like the question and the approach to solving the question. If you have any feedbacks, please drop in the comment and like and subscribe to this channel. Thank you. Bye bye.